Welcome to The Explainer. Today, we're going to pull back the curtain on all our technology and show you the surprisingly simple but totally brilliant ideas that make it all tick.
All right, so let's start with a big question. Maybe the big question. How in the world does a machine that only gets two things, on and off, end up creating the entire digital universe we live in? I mean, how do you get from a simple switch to this emoji? It seems like straight-up magic, but it's actually just a really clever series of ideas all stacked on top of each other.
So, our journey starts at the very bottom, with the absolute foundation. We're talking about a language built on just two simple states. This is, and I mean this literally, the bedrock of everything a computer does. And it all comes down to this little thing, the bit. It's just short for binary digit, and it's the smallest possible piece of information a computer can understand. It can only be one of two things, a 0 or a 1. That's it.
Just think of a 0 like a light bulb that's switched off. No juice, no electricity flowing. It's a totally clear off signal. Simple, right?
And you probably saw this coming. A 1 is just that same light bulb, but it's on. Electricity is flowing. A clear on signal. And that's really the whole alphabet a computer has to work with. On or off. 1 or 0.
Okay, so how do you build something complex that is something so, well, simple? I mean, with one light bulb, you've got two options, right? 0 or 1, off or on. But check this out. Watch what happens when you add a few more. With 3 bits, we can suddenly represent 8 different numbers. We do this by saying each position has a different value. The one on the far right, that's the 1's place. The one next to it is the 2's place. And the next one is the 4's place. Each spot is just double the one before it. So by flipping these switches in different combos, we can actually build any number we can think of.
Okay, so we've got numbers down. That's cool, but our digital world is way more than just numbers, right? It's filled with text and pictures and all sorts of things. So how do we make that jump from just numbers to actual meaning?
Well, the secret is, honestly, it's surprisingly simple. We all just agreed. A standard was created called ASCII, which is basically just a big chart where we all decided which number represents which letter or symbol. So when a computer sees the number 72, it just knows, we've all agreed that's a capital H. The number 73? Yep, that's an I, and so on.
So now, when a computer processes the binary code for 72, followed by the binary for 73, it's not just crunching numbers anymore. Because we all made that agreement, it's actually interpreting a message. It sees, hi.
Okay, so now we can represent information. But that's only half the battle, isn't it? The real power of a computer is its ability to process that information, to solve problems with it. And to do that, you need a recipe. You need a game plan.
To really get this, imagine you have to find a name in a massive 1,000-page phone book. Now, you could use the slow but steady method, start at page 1 and just read every single page. That'll work, for sure, but it's a really slow recipe or algorithm. Or you could be way smarter about it. You could open right to the middle, see if the name is in the first half or the second half, and then literally throw away the half you don't need. You just keep doing that, cutting the problem in half over and over again.
And the difference between these two approaches, it's not just a little better, it's absolutely staggering. The first way could take you up to 1,000 steps. But the smart approach, it will find any name in that same book in about 10 steps. Yeah, 10. That's not just a small tweak, that's a game changer. It's the whole reason your Google searches feel instant. This step-by-step recipe for solving a problem, that's what we call an algorithm.
So we've got these amazing, super efficient algorithms. Great, but how do we actually tell a machine that only understands 0s and 1s what to do? How do we give it those instructions? Well, you guessed it, we need another layer.
And that next layer is built on one of the most powerful ideas in all of computer science, abstraction. Really, abstraction is just the art of hiding all the messy, complicated details so you can focus on the important stuff. You do this all the time. When you drive a car, you don't need to know exactly how the engine works, right? Same idea here. We don't need to worry about every single bit and circuit. We can just use tools built on top of all that complexity.
And those tools are called programming languages. So on the left here, you see these visual blocks from a language called Scratch, which is made to be super intuitive. And on the right, you've got text from a more complex language called C. They look completely different, I know, but they are both telling the computer to do the exact same thing. Say, hello world. They're just different abstractions that let us talk to the machine and tell it our logic.
All right, let's zoom back out and look at the whole picture now. Because when you put all these pieces together, what you see is that modern computing is kind of like this incredible skyscraper, just built layer by layer on top of these abstractions.
We started at the simplest possible foundation, bits, just on and off. Then we built a layer on top of that to represent numbers. Then we all agreed on standards like ASCII to give those numbers meaning. On top of that, we designed really efficient algorithms to process everything. And finally, we built human-friendly code to actually write all those instructions. Every single layer just trusts that the one below it is going to do its job.
And that right there is the most important thing to take away from all this. This layered way of thinking, it isn't just for computers. It's an incredibly powerful way to think about any problem. It's about taking something huge and scary and breaking it down into smaller, manageable pieces. It's a toolkit for solving just about anything. So the only real question left is, what are you going to build with it?